Assalamu alaikum student. In today's lecture we have to discuss some of the structural theory regarding coordination compound, as these theories were put forward from very ancient times, but some of the theories are very famous for its approach. One of the theory between them is the Bloomstein-Jorgensen chain model, and this theory is also called Jorgensen chain theory. In this theory was proposed first by C.W. Bromstein and also accompanied by him with S.M. Jorgensen. This theory is put forward in the 19th century. So the main postulate of this theory are that according to them the complex containing some of the element or which we called the structure or bonding arrangement is little but somewhat different from now, as we have to see. For example, in this theory I have to show first by which compound they have applied. This theory is applied is basically by the complex cobalt trichloride hexamine, which contain 6 ammonia molecule, 3 chloride molecule and 1 transition metal, that is cobalt. Similarly, another example which they explain is cobalt trichloride, same, and also with 5 ammonia molecule, and also they explain the cobalt tri-molecule with 4 ammonia molecule. Here if you see they have not considered as which one is ligand here with the transition metal. As you know, in the modern concept you see or differentiate some of the ligands with chlorine and some of the counter ion or spectator ion with the compound. So in this case they have no clear cut identification, or they have no some of the bracket which you see in the previous explanation, which we called coordination sphere. In coordination sphere you know that there are ligands are present. So this is the thing which not explained. So according to them, in this compound they said that nitrogen could have 5 valency. You see here now in nowadays concept, nitrogen possesses 3 valencies, as it has 5 electrons in their outermost shell. But now in this case they propose nitrogen with 5 valency, and those with cobalt like cobalt. So we have to see here how they have 5 valency. So you see that nitrogen is chain here, one bond making in the chain, one bond making with the cobalt, this bond making with the other nitrogen atom, and similarly these 3 hydrogen can make bond. So the total number of bond, as they said, are called 5. So here this nitrogen is also 1, 2, and here 3 hydrogen atoms. Similarly, this arrangement is accompanied by this and this and this. So all the structure, if you see, the nitrogen atom is bonded with other 5 neighboring atom or neighboring bond. Similarly, here you see one thing, that chlorine is in some cases attached near, in some cases chlorine attached far, and between them is ammonia molecule. Similarly, so this we have to discuss in the next point, that is precipitating point, that which chlorine is precipitated and which chlorine are not precipitated. In this compound, when you put in water, there are some chloride ion which are separated or precipitated. So thus we are called that chloride ion are precipitated atoms or ions. So they explain this property with the help that some of the chloride ions which are attached directly are very near to the cobalt atom. They are non-ionizable, or this means they are more strongly attached than the rest which are far. So this by this attachment, they propose that the rate of precipitation for the chloride ion depends on their distance from the cobalt. So this is the point which they are explaining. So here they show some of the structure. In this structure, they shows that there are two possible structure according to precipitating, that in which the chloride ion are very near, so they are non-ionizable, and in this case the chloride ion are very far, so this means they are most easily attached. Similar in this case, some are directly bonded, some have one ammonia molecule, and in this case four ammonia molecules. So this means the rate of dissociation depend upon the distance from the cobalt. This is more easily ionizable, this is less easily, and that is non-ionizable or directly attached. Similarly, the case is the last one example also. So this Jorgensen chain theory explain the rate of dissociation and also some of the structure regarding to the nitrogen pentavalency. According to them, nitrogen possesses pentavalency. This theory could gain popularity, but suddenly failed because of the Werner theory, as Werner explained some of the point very well. So in this point I have to explain some of the basic point, that the basic structural geometry of the complex or coordination compound can be depend by their number of ligand. How many number of ligand attached, it directly shows the attachment of molecule. For example, we have coordination number 2. So this means the central atom is center between the ligand. So the two ligand take part. So that is why this compound called the coordination number 2 compound, which contain two ligand, that is represented by Ml2. M means transition metal, L means ligand. 2 means there are two ligand in this compound, and this structure in the modern structure elucidation, this compound has two ligand. So this means they are align themselves at 180 degrees. So this means the final structure will be linear. So this linear structure means that they are far apart from each other, and they make themselves more possible that they have maximum repulsion. So this point is explained by the Vesper theory. As you know, in Vesper theory, the electron domain repulse one another. They have repulsive force, or they maintain themselves at maximum distance. So this repulsion theory makes sense that these two between the central transition metal have to stay apart, and this the only possibility is 180 degrees. Similarly, if we go further for coordination number 3, the same concept apply, that we have to keep these three ligand by distance up to 120 degree, or means that you have to keep them at maximum position at which they appear at maximum repulsion. So this is we called ML3 structure, which contain central metal transition central transition metal, and contain ligand, three ligand. So they are some of the example are here see in the formula. For example, we go forward next to coordination number 4. Here we also explain there are one central transition metal and similarly 4 ligand attached. So there are the possibility of two structure. One is tetrahedral, as you may see in basic organic compound, just like the structure of methane. And here the structure is planar. Planar means they are laid down on the plane, but they have maintained their maximum repulsion. Similarly, the tetrahedral structure also maintain their maximum repulsion. 109 degree, 0.5 degree angle between all the bonded atom. Or similarly, we called here the atom, not atom just like methane, but we are called this ligand. Similarly, in coordination number 5, you have 5 ligand around the central transition metal. These 5 ligand arrange themselves in two form. One is, for example, this is the basic form is a planar, but above it is a fifth ligand which is on the top and making the structure of pyramid. That is why we call this structure a square pyramidal. Similarly, in another possibility, they have trigon between the center, that is a gone shape, and one is above and the other is below. So this means they have two pyramid. One pyramid making from the above and the other pyramid made below. That is why they are called trigonal bipyramidal. So trigonal means there is a trigon between the center. One pyramid is above and other pyramid is below. Here in the coordination number 6, which contains 6 ligands, so you may see one central transition metal, and here you may see two there you may see in the same central transition metal or 6 ligands. So again, if you see here one concept, as the number of ligand increasing, the possibility of structure is more complex, and also they have a peculiar shape. So that is why now elucidating the structure, in this case ML6, we have also possibility of two structure which contain one is center square shape, and in this case the trigon, one trigon is above, the other trigon is below, so making the shape of a prism. And here is a dome shape, or simply pyramid. One pyramid is from the above and other pyramid is below. So that is why this structure are have a little bit trigonal prism. This is a trigonal prism, and this is a metal. This is octahedral in shape. For example, octahedral has to explain this is you have to count faces from here. One face, the other face, this face, and one face is behind. So there are 4 faces. Similarly, the 4 faces are that is below also. So you have to see a little bit more clear this octahedral and trigonal shape. In this case, coordination number 7. So in coordination number 7, only one possibility of one structure. So between the center, if you analyze, there are 5 ligand, and one ligand is above and the other ligand is below. So this structure is also a pentagonal bipyramidal. Pentagonal means as 5 ligand between the center and one pyramid above and one pyramid below. That is why they are called a bipyramidal. As we go further, so the structure is going to more complex by the addition of more ligand, that is ML8 ligand. So here you have 4 ligand above, 4 ligand below. In this case you have multiple 8 ligand, but in a random structure. So that is why the structure is a little bit opposite of prism. So that is why they are called square anti-prismatic. And the below is between, if you see here, is all side have trigon, trigon, trigon. That is why they are called trigonal, though the dodecahedral. So dodecahedral means they have 12 faces. If you have the structure, or you have count these faces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and one is approximately fully behind the structure, and one is fully front facing. So now if you going to further the structure of the coordination number 9, which contains 6 ligands, so the structure is more complex. So that is why they are called tricap, trigonal, prismatic. For example, if you see in the center, it which is actually the prism shape, but here you see there is a trigon between the center. One trigon is here, 1, 2 and 3 ligand, and similarly tricap means that have 3 foot, 1, 2, 3, 1, 2, 3 from the upper side and also from the below side. That is why they are called tricap, trigonal, prismatic molecule. This is the more complex structure, a little bit, and more magnified view, the tricap, trigonal, prismatic structure of Ml9, which contain one central transition metal and 6 ligands.